is the Physical Science Section 18.2 lesson video, and as always, if you want my videos in one spot, then just subscribe to my channel. Alright, so we're going to talk a little bit more about electromagnetic radiation, and we're going to talk about the electromagnetic spectrum. So we're going to talk about the different types of waves. So a scientist observed that when light is passed through a prism, the temperature of the light at the is lower at the blue end and higher towards the red end. He also concluded that there was invisible radiation beyond the visible spectrum. So what he did was he set up a prism and he put thermometers there and measured the temperature of the different colors of light, and noticed the different colors of light actually had different temperatures. And he concluded that there must be waves on either side of the rainbow that we actually can't see. So the full range of frequencies of electromagnetic radiation is called the electromagnetic spectrum. The electromagnetic spectrum includes radio waves, infrared waves, visible light, ultraviolet rays, X-rays, and gamma rays. Alright, and so this has them all right here. So you can see that radio waves have the longest wavelength, lowest frequency. Next is microwaves. Microwaves are actually a type of radio wave. Then we have infrared, visible, ultraviolet, X-ray, gamma ray. And you'll notice over here, our wavelength is very, very short, so very high frequency. And of course, that high frequency means those particles have a lot of energy, so they start to get dangerous to enter our bodies. Like we all know X-rays. Where does the X-ray technician go? They go behind the wall because they don't want to be exposed to those all the time. Whereas radio waves are passing through the air all the time, and we're all exposed to those, but they have much lower energy, so they're not as dangerous. So radio waves are used in radio and television technologies, as well as in microwave ovens and radar. So what's the difference in FM and AM radios? In AM radio, the stations have signals with varying amplitudes. So here's just a normal wave, and so if you look, AM, we have low amplitude, and then it gets high, and then it gets low, and then it gets high. So AM, the A stands for amplitude. Then in FM radio, the stations have signals with varying frequencies. So if you look, we have short wavelengths, so high frequency, lower frequency, high frequency, lower frequency, like that. So the FM means that the frequency is changing. The shortest radio waves are called microwaves. Microwaves also carry cell phone conversations. Bet you didn't know that. Okay, so we know microwaves heat up our food in a microwave, but they also are what allow our cell phones to work. That's why you'll see lots of studies about, oh gosh, are the cell phones frying our brains and things like that. So infrared rays are used as a source of heat and to discover areas of heat differences. Thermograms are color-coded pictures that show variations in temperature. So whenever you see the red lamps that are heating food, that's infrared rays. And then this is a thermogram. It shows you the different colors. And this right here is actually what I was just telling you about on the previous slide about the cell phone. So here's the man when he has not been talking on the cell phone. And the cooler colors like green, blue, purple, those are cooler temperatures. The warmer colors, yellow, orange, red, those are hotter temperatures. And here is what his thermogram looks like after a 15-minute cell phone call. And so some people feel like, oh gosh, that difference in heat right there, those microwaves that were close to his face, is that going to cause brain injury later in life? Of course, that's inconclusive right now. So here's the electromagnetic spectrum again. So we have our radio waves over here. We have our infrared rays. Our visible light is actually a very tiny portion. So they pull it out so you can see the rainbow of color. So of course, red is closest to infrared, and purple or violet is closest to ultraviolet. So then you have your UV rays, that's what's responsible, of course, for getting sunburn. You have your X-rays and gamma rays. And so again, as you look, these are the longest wavelengths to the shortest wavelength, or lowest frequency to highest frequency. Remember, they're indirectly proportional. So let's talk about them. So ultraviolet radiation has higher frequencies than violet light. We cannot see it. Ultraviolet rays have applications in health, medicine, and in agriculture. And like I said, that's what's responsible. That's what you try to protect yourself from by wearing sunscreen. X-rays have high energy and can penetrate matter that light cannot. X-rays are used in medicine, industry, and transportation to make pictures of the inside of solid objects. So of course, most commonly X-rays are used in, doctor's offices to see inside your body, but they're also used, for example, on airplanes. Like when you're passing all your bags through, they have X-ray technology to look inside your bag and look for, metal objects and things like that. And then gamma rays have the shortest wavelengths, which means the highest frequency in the electromagnetic spectrum. It's about 0.005 nanometers. Whew, that is very tiny, or less. So gamma rays are used in the medical field to kill cancer cells and to make pictures of the brain, and in industrial situations as an inspection tool. So gamma rays still have uses, but they are very, very, very powerful. So, section assessment. List the kind of waves included in the electromagnetic spectrum from longest to shortest wavelength. Okay, well, longest was, of course, microwave. Well, longest was radio waves in general, which includes microwave. So longest is radio waves, which includes microwaves. Next was infrared rays. Okay, making sure I was going in the right order from longest to shortest. Okay, infrared rays. Next was visible light. Then next was UV rays, or ultraviolet radiation. Next was X-rays, and then gamma rays. Alright, how are AM radio waves different from FM radio waves? Well, remember, AM radio waves differ in, what would start with A? Amplitude. And FM have changing frequencies. Okay, so AM has changing amplitudes, and FM has changing frequencies. Alright, and then what type of electromagnetic waves are microwaves? Well, I just accidentally made a mistake up here and started with microwaves. Remember, they are radio waves. Okay, so radio waves encompass all of that. Microwaves, radar, AM, FM, all of that. Alright, so microwaves are types of radio waves. Alright, so hopefully now you know a little bit more about that electromagnetic spectrum, and remember, as wavelength increases, frequency decreases.